is parent functions and transformations. We're going to go through many of these terms: parent graph and function, constant function, identity function, and quadratic function. We'll do translations here in a moment. Reflection and dilation we will get to in class. So here is the constant function, which we've covered. So horizontal lines. So they are in the form of f of x equals a, so that number, and of course that's y, which we've done. And we have done lines in the form of y equals mx plus b, but they all fall into this family of functions, or these parent functions of f of x equals x. So y equals x. So that means that this parent function has a y-intercept of 0 and a slope of 1. So any of the y equals mx plus b lines fall into this identity function family. What we're most concerned with are the absolute value functions. So their parent function is f of x equals the absolute value of x, and you're going to see another form of this function. This gives you the domain of the absolute value function, the parent. It's a set of real numbers, and then the range for the parent function is greater than or equal to 0. And of course then the range will be different for each individual absolute value function, but you'll be able to see their range, and we've talked about a few of those. Your quadratic function, they are in the form of f of x equals x squared, and then we'll do translations, reflections, and dilations of the quadratic function. So here are the vertex form. So we're going to take the basic x squared, or the basic absolute value of x, and we're going to talk about what is this hk. It's the vertex of the graph. And what do I mean by a vertex? So let's look at another graph. So here's one, for instance. We have the equation y equals 1 times the absolute value of x minus 3 plus 2, and you get a vertex of 3, 2. Well, those 3, 2 are somewhere within your equation. And where do we get that? This is a translation, which we will go through. It has gone from your parent function, which was right here at the origin, and it has been translated, and we will go through those. And here is a quadratic function, which has gone from the parent function, which was also at the origin, and it is not just an x squared, it is 1 times x plus 4 squared minus 2, and you'll see your vertex is -4, -2. This is also a translation, so it has moved over and down from your original parent graph, and we will discuss those as well. So I wanted you to see that. And that vertex form was very important, so I hope that you run back or pause it and pull it back and make sure that you get that down. You should have learned previously that in absolute value functions, as in y equals the absolute value of x minus 3 plus 2, so this was algebra 1, to find the vertex, the statement within the absolute value is set equal to 0. So you should have done this in algebra 1. This is why in your vertex, it seems the x values are the opposite sign from its sign in the problem. So on that translation, this was your equation, and then your vertex had a +3 as the x value in the vertex, and this is why, because you take all of this and set it equal to 0, and you get your vertex value. I will discuss straight from the vertex form how you get hk. And we'll go into translations, dilations, and reflections specifically in class. Those are your notes.